fairly big company, and we spend and invest a lot of money on fundamental research. So we have about 100,000 employees and about 1,800 in US, and we have 2 research labs, one in Cupertino, one in Houston, New Jersey. As you can see, we have done a lot of leading, new innovations, and most important is, of course, we spend 7% of our budget on fundamental research. A lot of these things appear as products today. Some of things, some of these technologies we are integrating for future. I want to show some examples in big data and public safety of what NEC is working on. Just one more slide on NEC. We focus on national level public safety solutions. We provide solutions in law enforcement, national ID, passports, border control system. We have the largest footprint in fully automated border control systems. So I want to share some experience on what exactly are we doing as a big data initiative in this area, specific to this area. And of course, because we have background in computer and communication, we are trying to combine both communication, data-centric solutions along with biometrics to provide some big data solutions. So NEC initiative in big data is, especially specific to public safety, is we are looking at some kind of a fusion-based big data processing, which involves both offline data, which is pre-recorded archive data, as well as real-time data. And majority of our research is to combine these two to provide a real-time analysis and analytics. So if you look at big data for public safety, I'm sure you heard from morning CPD has done a lot of initiatives. The biggest problem in public safety at national level, what we see is there are multiple disparate systems, and many times they don't talk to each other. They're all in silos. You have a national ID system, you have a credential system, then you have a law enforcement system. They're all in their own silos. Approach to do this, many states and countries have gone to Fusion Center, where they're trying to establish some way to have interoperability and intercommunication between agencies. But that's a slow process because not every agency will be equipped to do this right away. Other alternative is in public safety is to look at what are the data. If all the data are being archived today, can we bring all this archive and start doing data mining on them? I think this is a more practical and easier problem to solve than look at the interoperability and interagency communication. So our focus is to look at this last bullet point. So if you look at a public safety scenario, you have law enforcement, which has a lot of criminal records. You have secure credentials, where we have driver license, visa, passport. And then you have border management, where we know that which person came to this country and which person exited and at what time. And we also have public data, like social media, Facebook and Google and so many other. So we should have the ability to bring all this data and do proper analytics and archive this so that when an event happens, we have the ability to go back and say, show me an individual who was in his 40s who came to this country through this particular entry point between this time period. And once you get that particular data, then you can go back and say, okay, I am interested in this individual. And now look at his photograph and say, select that photograph and say, I would like to now find, how many times this individual came to this country in the last 10 years. So this is, of interest to us, and many countries want this kind of a system. You did talk about this. So we are looking at taking a lot of this analytics information to come up with these type of systems. Now, what is the role of biometrics in big data? Because if you look at a visa or immigration system, all you have is simply an information saying this individual booked on this particular flight and he landed in this country and left on a certain day. But that is just an information. And the credential that individual may have used may be completely false. But if you attach a photograph to that, now the photograph can give us the biometrics information. The moment we have such biometric information, it's possible for us to now link this metadata to say this individual, even though he used false demographic data or biographic data, but he is associated with this biometrics, and that biometrics is associated with another set of data. And of course, this individual also has another identity in some other system. So we want to establish these types of links so that our query, the natural language query, what we do during investigation will be more meaningful. The types of components we are using, both of our labs, US labs, are involved in machine learning and pattern recognition technologies. So we use several components. For positive identification, we use facial identification, fingerprint, palm, iris identification. And also we have object detection. We can look at a car and specifically say this car is of this model and potentially of this year make, not just the color and the shape of the car. So that is also something we are working on. And we generate analytics by looking at photographs. We can estimate age, gender, and also the clothing. We can extract the clothing features saying that this individual was wearing a suit with a potentially white shirt. And also we do behavior analysis. We look at motion pattern, and you saw some examples from Professor today. Some of our cameras in, for example, Japan, they're already equipped with this technology where if you're driving in Japan and if you're drunk, and we can look at the pattern of driving and automatically mark that this particular individual may be committing DUI. So these are already in the field and deployed. So if you look at the positive identification, not all the technologies are same, because 10 years ago, facial identification had a false non-match ratio of about 30%, 0.3. Today, this technology is mature to a level where this non-match ratio is something like a 0.003. So these are in orders of magnitude. It's not just small improvement. Why that is happening is we're looking at real what exactly happens in the field and trying to bring such aspects into the technology. For example, doing facial matching, even if you get a 2D photograph, we just don't enroll the photograph as it is. We internally create a 3D wireframe model, rotate the face in potential direction, which may happen in practical area, and encode that. Similarly, when we are trying to match, we do not look for the entire face. We look for statistically similar area which are clear. We only try to match that area. When you do this, you get the best accuracy. In some of the NIST ranking, our technology has achieved accuracies in excess of 97%. And in object detection, as I mentioned earlier, we are investing a lot of resource in this, not just for public safety. This is also for automated drive, because in Japan, many car vendors are looking at, can we have a fully automated driver in the car? So we are looking at how to detect objects on the road. So some example on generating analytics from the image. This is an example of a subway station in Japan. And in real time, we can look at a person, we can count how many people are going there, and also what is the particular age of that person, and also gender. This is done in real time. So when we get this analytics, we take that video, take this metadata, and start archiving this. So in future, you can do a query on this. We also do facial expression. I had a video clip because it was simulated. I did not want to show. You can see the facial expression. Somebody smiles or is unhappy. It's easy to. It's not easy to do that, but it's a technology which is practical. And of course, clothing and wearable objects. And actions. Many of the systems we have deployed globally, we do look for certain types of activity. So, like a person is pointing, or see, that's a false one, even though she is keeping her hand, but it still detects cell-to-ear. And this individual also, it looks like cell-to-ear, but actually she's trying to just. So there are false triggers also. Keeping objects. These are some video clips from our deployment. So when we get these types of data, in the past, we used to use this for real-time analysis. So in real-time analysis, an operator gets a notification saying somebody left their luggage and walked away. And immediately, if the operator goes there, the security officer goes there, that individual will come back and pick up the luggage and start walking. So when you start triggering too many unwanted alerts, after some time, the users basically give up and say, this system doesn't work. So real-time solution is something, a difficult challenge. So what we have done is we have taken all these components, we have brought all of them into a new product called as Video Meta Search. Right now, we are deploying this solution in Latin American country, and in a specific city with about 800 cameras. So what we are doing here is we take all the videos at the end, So when you have a video surveillance system, you have all these videos feeding data to a VMS center, and in the video management center, you have real-time operators are sitting there looking at this video. But once that operator review is done, that video gets simply archived today. So what we do is when the VMS is trying to archive the data, we take a copy of that video, do analytics, and we establish analytics metadata. So, and after that, of course, the video gets archived. So once you do that, in future, if some event happens, like a Boston event or anything of that sort, you can go back and do a natural language query and say, show me an individual wearing, a black suit in his 30s. So when you do that, it will bring, you can give a time range. It will bring associated video clips to say, these are all the video clips in which I can see an individual of your description. Now, what I can do is, as soon as I see that, I can review some of this video, go back, select one of the frame, and say, okay, this is the guy, this is the face I'm looking for. So once you do that, now you drill down from a simple natural language query to more specific person. And once you do that, now we go look for not only a person wearing this clothes, but with also the specific facial features. And when we do that, of course, the video clips will change. So an investigation officer can, keep on doing this until he gets the right person. So this is one of the solution we are deploying right now. It's in pilot. The customers really like that, but now they're asking, can you do this on time, in real time, not just offline. So for that, we are also looking at building some rules engine. Maybe we can look for some small events and notify them, but it's a very difficult challenge. So these type of solutions in public safety play a lot of role because it's not just for monitoring an ongoing crime. This also leaves history where you can go back and reconstruct and try to analyze why this individual committed this crime and how he was able to plan this, how he was able to do that. That is something is very useful to enhance public safety. And of course, this provides a lot of intelligence to prevent such events in future. So we are spending a lot of our research dollars on Safer City initiative. This is one of the initiatives we're working on. That's what I think.
Wonderful. Thank you, Kris.